All right, today we have Keeper 8.2, average function value and mean value theorem. All right, so to start, we're going to start with our average function value. A lot of times you'll see that abbreviated as your fave or your F average. And that function is given by 1 over b minus a times the integral from a to b f of x dx. All right, so first example, we want to find the average value of the function over the given interval. So we have the function of f of x equals negative x squared plus 2x plus 1, and we're doing that over the interval from 1 to 4. And so this is just a matter of plugging into your function. And so we have our f average, or our fave, of 1 over b minus a. So b is our 4, and a is our 1, so we do 4 minus 1, and then the integral from 1 to 4, or a to b, of the function. And so from here, I just simply clean it up and integrate. So I have 1/3 from the 1 over 4 minus 1 times the integral of this, which was negative x cubed over 3 plus x squared plus x from 1 to 4. So I get 1/3, and then I plug in my bounds. Notice I put the 1/3 in parentheses or outside of the parentheses, so I make sure to distribute it to every piece of this. But I have negative 4 cubed over 3 plus 4 squared plus 4 minus, and then plugging in 1 to the bottom, I get negative 1 cubed over 3 plus 1 squared plus 1. So cleaning that up, I get 1/3 times negative 64 over 3 plus 16 plus 4 plus 1/3 minus 1 minus 1. And cleaning that up some more, I get 1/3 times negative 21 plus 20 minus 2, which simplifies out to be negative 1. All right, so another example is very similar. I'm going to plug this function into my formula. So I get 1 over b minus a, which is negative 2 minus negative 3, integral from negative 3 to negative 2 of my function. All right, so cleaning this up, this 1 over negative 2 minus negative 3, I get 1 out there. And then the integral of this inside piece, just like a quick integral, is going to be the same thing over 2. And so once I plug in my bounds, I get negative 2 times negative 2 plus 4 plus e to the 2 times negative 3 plus 4. Again, that's because this 2 and this 2 canceled out, and this out here was just 1. All right, so cleaning that up some more, I get negative e to the 0 plus e to the negative 2, which is simply 1 over e squared minus 1. All right, so next example, very similar. This time we're doing it with the trig function though. So we're going to do 1 over b minus a, which would be 1 over 3 pi over 4 minus pi over 2, times the integral from pi over 2 to 3 pi over 4 of cosecant squared dx. Again, cleaning that up, I get outside the integral 1 over pi over 4, and then the integral of cosecant squared is negative cotan x from pi over 2 to 3 pi over 4. All right, so this piece that's outside, I'm going to flip that. So it's going to become 4 over pi, and then I'm going to plug in the bounds of my integral. So I get negative cotan 3 pi over 4 plus cotan pi over 2. Now using unit circle values, I'm going to end up with 4 over pi times 1 plus 0, which gives me a final answer of 4 over pi. All right, so the next thing we need to look at is our mean value theorem for integrals, which is actually the same exact formula for your average value, except for that 1 over b minus a, they went ahead and multiplied to the other side of the equation. So technically, it's really kind of calculating the same thing. The only difference is they're trying to figure out what value gives you the average value. What is the actual C value? Or x value, if you want to look at it like that. What's the x value that gives you the average value? So the average value theorem tells you the average value, where the mean value theorem tells you what x gave you that value. Let's work a couple examples. So again, we have a function over some interval. I'm simply going to plug into my formula. So there goes the formula again. Integral from a to b f of x dx equals f of c b minus a. And so plugging into that formula, I get the integral from 0 to 2 of f of x, which is x minus 2 root x dx. And then equals, over here, I'm simply just putting in c instead of x. So I say c minus 2 root c times b minus a, which is 2 minus 0. All right, so cleaning that up, I get the integral on the left-hand side to be x squared over 2 minus 4/3 x to the 3/2 from 0 to 2. And then what I did on the right side was I took this 2 minus 0, which is just 2, and I distributed it into my parentheses. So I get 2c minus 4 root c. Now again, working on that left-hand side and plugging in my bounds, I get 2 squared over 2 minus 4/3 times 2 to the 3/2. And then technically I plugged in the 0, but we should be able to tell that that 0 is going to just give us 0 when we plug it in. So simplifying that some more, I get 2 minus 8 root 2 over 3 on the left-hand side. And then simplifying by dividing everything by 2, since everything was even, I get 1 minus 4 root 2 over 3 equals my right-hand side of c minus 2 root c. And then I would use my calculator to solve. So I would in my calculator, I press the solve button, so menu 3 and then 1, and then I would type in my function, comma c, press enter, and I get these answers. So I get c equals 0.438 and c equals 1.791. Just make sure whatever c values you get actually fall in this original interval of 0 to 2. All right, so next example, again plugging into my formula, I'm going to have the integral from 1 to 3 of 9 over x cubed dx equals 9 over c cubed of b minus a, which is 3 minus 1. All right, so simplifying that out and integrating, on the left-hand side, the integral is negative 9 over 2x squared from 1 to 3, and on the right-hand side, I'm going to end up with 18 over c cubed. All right, so plugging in my bounds on the left side, I get negative 9 over 2 times 3 squared plus 9 over 2 times 1 squared. And then simplifying that left-hand side some more, I get negative 1/2 plus 9/2, which is really just 4 on that left-hand side. So multiplying both sides by c cubed, I get 4c cubed equals 18. I'm going to divide both sides by 4 to get c cubed equals 9 over 2. And then I'm going to cube root to see that my final answer for c is the cube root of 9 over 2.